All right, today let us deal with what we call measure of variation. Measure of variation is what we are going to be discussing today. Before we move to that, please let us try to understand why do we measure the variability itself. The main purpose or the main reason why we measure variability or variation is actually because we wanted to know how much we can be confident enough with our prediction on the population when we use mean or mode or median as center of tendency. But in particular, mean is actually our major aspect. So we want to know how confident we can be to say that mean is okay to be the value for central tendency. So we need to measure the variability to be understand or to be able to know how much we can be confident enough. Now let's see another reason why we still measure variability is because it tells us the shape of our distribution most of the time. Yes, it tells us our shape of distribution. For example, is our distribution going to be normal distributed? Is it going to be skewed? Is it going to be highly skewed? When we measure the variation, we are going to know that too. So let's see how we measure variation or variability of any data set. To measure variability is quite easy. All you need to do is to calculate the mean of the square deviation. In fact, some people call the variance the same name. They might call it mean of the square variation. Even by looking at the name, mean of the squared deviations. That means first thing we are going to need is that mean. Before we can calculate our variation, remember the variation has of two types. Either you measure the variance or you measure the standard deviation. Although there are some other ways of measuring variability using the range. I think many people would have used to that. You have learned that range are always measured by finding the difference between the maximum value and the minimum value. Although there are some other kind of range which we are not going to be discussing right now, like decile, interdecile range, interquartile range, and so forth. So, but what we are going to be looking at here is actually the variance and the standard deviation. So let's see. To measure the standard deviation, one particular thing that is very important, or let me say the step one, is to calculate your mean, because actually you wanted to know how far each data, how spread they are from the mean. So mean is very important. And who doesn't know how to calculate the mean? I don't think anyone does know that. And if you don't know, the easiest way to calculate the mean is to sum all the value, all the data sets you have, then divide it by the number of observation or the number of data you have. That is easy way to calculate the mean. So let's see. If you are able to calculate the mean, remember S bar is always used to denote mean in any formula. In most formula, you'll be seeing in statistics. So what else should we do? What else should we do when we are able to get our mean? The next step to do is to calculate the deviation. Remember, the name for variance is mean of the squared deviation. Meaning is that there's no way you can do to calculate the variance without getting what we call deviation. What is deviation itself? When you say deviation, we are actually trying to calculate how far each, or let me say how much each data deviates from the mean. So when you say something deviate, that means we are trying to talk about how far it is. For example, let's say the mean is 25. So if a data set happens to be 30, we said such a data deviates from the mean by 5. Another data set might be 20. We still say that such data also deviates from the mean by 5, because actually the difference between 35 and 20 is 5, and the difference between 25 and 30 is still 5. So it's like we are measuring the differences. Just subtract your mean from your data set, and that will give you the deviation. Now let's see. Meaning is that if you wanted to calculate the deviation, you can simply represent the formula by saying S minus S bar, where S bar represents the mean, while S represents the observation in the data set. Now let's see. The next thing is to square. Remember we said the definition or the area, the brief definition for variance is mean squared deviation. So that's the actual formula for any variance. So that means we need to square too. So after getting the deviation, you square the deviation itself. That will give you the square deviation. Then after you've gotten that, then all the data set that you get after that, find the mean. And how do you find the mean of any data? You sum all the data divided by the number of data. That means after squaring all the deviations, then you sum all the square deviations together divided by the number of the data sets you have. I mean, this might be look a little weird, and this is the formula we are trying to see. As you can see, s minus s bar, then square. This thing represents the summation. You sum everything together, then divided by n. The only thing that makes this thing different is that we are dealing with s minus s bar here. This formula resembles the formula for calculating the mean, if you still remember. All right, let's take a two-line example so that we can understand what we are trying to discuss here. Example 1. The question here says calculate the mean and the variance of the following that is showing the number of unemployed noted in the week. See, we have 986421 as our data set here. Let's see how we calculate that. The first thing do not forget is to calculate the mean. So let's see how I do that. See, this is all the data sets I have, 986421. So I sum everything together, I will get 30. That's my summation x. So after getting 30, I can see 1, 2, 3, 4, 5, 6. I have 6 data sets here. In that case, 30 divided by 6 will give me 5. Remember, that is the formula for calculating the mean. So I've just gotten my mean here. So my mean here is 5. Then the next step is to calculate the deviation, as I showed you here in the table below. I need to calculate the deviation. Remember, the deviation is subtracting the mean from each of the data sets. So these are all my data sets. So I will start subtracting the mean from each of them. So I will have 9 minus 5, that is 4, 8 minus 5. I continue like this. I get some negative value, I get some positive value. Please note that you are going to know if you are wrong. But at this second step, if you realize that the sum of all your deviation does not give you 0, if you sum all the deviation here, 4 plus 3 plus 1, that will give you what? Yes, that will give you 8. Minus 1, that gives you 7. Then minus 3, that gives you 4. Minus 4, that gives you 0. So every deviation from the mean, if you sum them together, they are going to give you 0. And that is the reason why we always need to do something called square. So everything here we need to square. So 4 square here, sorry, this is a mistake. I actually wanted to put all these two in form of power. So 4 square will give you 16, 3 square will give you 9, 1 square will give you 1. So I continue like this until I get 16 here. So these are all the square of deviation. Now the next thing is to calculate the sum of all the square deviation. And that is what I have done here. If you add 16 plus 9 plus 1 plus 1 plus 9 plus 16 here, you are going to get 52. So this is the sum of all the square deviation. Now, the next thing is to do what? Is now to calculate our variance. Remember, our variance will be the sum of all the square deviation divided by the number of data sets. And how many data sets do we have? We have 6. So if the sum is 52, just like we have here, then we can proceed to calculate the variance. So our variance will equal to s minus s bar, then square over n. And that means 52 divided by 6, which has given me 8.67. And this is my standard, this is my variance rather. So this is very easy logic way to calculate the variance. It is not hard at all. Just follow the same step as I've stated. Follow step 1, do step 2, do step 3, then step 4. You've gotten your variance. So note that the symbol for variance is always denoted by s squared. And why? Because actually, whenever you wanted to calculate the standard deviation, you use square root of variance. Please note, so in that question, if I need to calculate the standard deviation right now, it is very easy. All I just have to do is to find the square root of the value which I've gotten for my variance. And in that case, I could have done something like square root of 8.67 will give me my standard deviation if I need to calculate that. But let's see. What is standard deviation itself? Like I said earlier, standard deviation is just a typical level of variance. And it is very easy to calculate. Just find the square root of your variance and you get your standard deviation. Let's take a look at a sample. Let's take a look at a sample on that. Imagine the one we calculated earlier. You can see we follows all these steps. The only thing is that we just include another step, and that is to find the square root of the variance. You can see everything I have done here. So when I calculate the square root, I get 2.94, and that's my standard deviation. So in that case, there's no way you get your standard deviation without getting the variance. Variance comes first, then standard deviation follows. And question is done. Now, shall we take another example? In that case, sorry, I should tell you that this is now the formula for standard deviation. You can see it is very similar to that of variance. The only difference is that we apply the square root on it. So that is that about that. Before we move on, it is very important that we understand the difference between sample and population, because most of the time you are going to be seeing these two formulas in different books. So there is something called population standard deviation, and there's something called sample standard deviation. Remember, you would have learned about population and sample before. When you are dealing with the whole data, when you are able to access all observation, all the data in a certain thing you are trying to target, we said you are making use of population. But when you select part of it, for example, you are targeting to get the value of the on average, the age of students in the University of Ibadan. In fact, you might try to conduct research and try to add the age of everyone in the University of Ibadan. We said you are selecting population. But if you just decided to take Faculty of Science alone and use them as your research, we said you select the sample. So sample is just like you are selecting the portion from the whole, while population is the whole itself. So the formula for the whole is always denoted by this. So we use N. And when you are dealing with sample, you use N-1. This N-1 is also referred to as degree of freedom. It is just a way of doing adjustment because of the fact that sample cannot totally represent the population. And to make sure that we don't underrate or underestimate, we use -1 to cover all the error which might happen. Sample can never be equal to population. You cannot compare someone that take the whole and someone that take the portion. So that is just the difference between the formula. So when the question is giving you the sample, you use this. And when the question is all about the whole population, you use this. All right, let's try to do one more example. Example 2 now. Let's take a look at this. This is going to be a real practical, let me say, how we make use of standard deviation in the real life application. Let's see. The following table shows the number of years in the prison that Judge A and Judge B gave all defendants convicted of assault. You can see Judge A and Judge B give the following for a kind of assault. Now let's see, the question says calculate the number of years you could be given on average by each of the judge if you commit the same crime. Question 2 is, what is the standard deviation for each of the judges' sentence? If you are given this, okay, let's answer this question. For question 1, the question asks about how much you can be given by each judge on average. That means indirectly we are asked to calculate the mean. Now let's see how to calculate the mean here. How do we do that? This is quite easy since we have all the data sets. These are gotten from what we have from here. Yeah, I've gotten this from here. And see, so 30, 30, 34, 30, 31. So all these data are listed out here for Judge A. This is all the data sets I have for Judge A. So, sorry, it's even actually, I really wanted to write months in the question. So these are the data sets we have for it. Now look at this thing. We are going to apply the same way. We need to calculate the mean first. So that means we add all these things together. If you add this number together, you are going to get 198. So that is the sum of all the data. Then divided by how many data? And that is 6 if you count. So divided by 6, that will give me the mean. So the mean here is 33. Then we follow the step 2, and that is to calculate the deviation. So that means we subtract the mean from each of the data sets. So we subtract 34 minus 33, 1, 30 minus 33, we do that. Now let's see, 1 minus 3 minus 2, 0, 3, 1. If you try to add everything here together, you realize that it's equal to 0. Remember, that is the thing I always ask you to always check when you are working. Always check if your standard, if your deviation is still okay. If this thing does not give you 0, it means there is something wrong somewhere. So we can proceed. That means we need to square all the value here. So 1 square will give us 1, minus 3 square will give us 3, minus 2 will give us 4. So we square everything here, and that is 3. We've gotten that. So we sum everything together. Remember, we sum all the square of deviation, and that gives 24. Now we can calculate the variance by just getting all the sum divided by the number of observation. And what is the number of observation here is 6. So the sum is 24 here. We say 24 divided by 6, and that gives us 4.0. So that means our variance here is 4.0, but we are interested in getting the standard deviation also. So our standard deviation here will be square root of 4, and that is 2. So that means for Judge A, on average, you can say Judge A is going to give someone 33 months or 33 years if we are working in years. 33 years in prison if you commit such a crime. Because actually we've got some data on how Judge A presents his sentence anyone who commits such a crime. And we are able to say that on average, if you commit the crime, Judge A is going to sentence you 33 years in prison. But the standard deviation for Judge A is 3 years, or you say months, if you are calculating in months. Okay, let's see for Judge B. For Judge B is going to, we are going to do the same thing. We add everything here together, then divided by 6, and that gives us 30. You can try to pause the video and sum it yourself to confirm that. The next thing is to subtract each of this thing from each data set. We need to subtract the mean from each of the data set, and that is what we are doing here. You can see, second step. Then another thing is that we need to square, just like normal way we have been doing it. Then after squaring this, we see all the results. And the sum of everything here gives us 4. This, you can check this also and see to realize that it's the sum up to 0. If it's not sum up to 0, then it's a sign that there is error. Okay, now that we have squared, then we need to divide it by the number of sample, and that is 6. So 402 divided by 6, that gives us 67. So this is our variance. So 67 is the variance here. Then the standard deviation can easily be calculated by finding the square root of the variance, which is square root of 67. So square root of 67 here is going to give us what? 8.18. So now you can conclude that on average, if you commit the same crime, Judge B is going to give you 30 years in prison. So that is what we can denote, or what you can deduce from Judge B. And we are able to confirm that the standard deviation for Judge B is 8. We can neglect the other family and just say 8 months in prison. Now, the question asks something interesting. Let's go back to the question. The question asks what, on average, each of the judges is going to commit. We are able to answer question 1. We know how much they can give us. But the question 2, we have answered that. But the question 6 says, if you are given the chance to select between the judge that will make your sentence, if you commit the same crime, which one will you prefer? Will you prefer Judge A to Judge B? Now, this is something we need to understand. Actually, if you look at the data set, our conclusion at the end of the mean, you realize that Judge A on average will give 33 years. Judge B on average will give 30 years. I know many of you, if you are given this kind of thing, you will probably wanted to go for Judge B. Because in fact, on average, Judge B will give less number of years in prison compared to Judge A. But that is not the right conclusion. We need to compare what we call the standard deviation. This is the reason why we study standard deviation measure, or the reason why we measure the variation. Now let's see. On average, when we discover that on average, Judge A is going to sentence us 33 years, but the standard deviation is 2. This shows that Judge A is very consistent. I don't know, maybe you get what we are trying to say. Here's what I'm trying to say. What I'm trying to say is that Judge A has a larger mean, but smaller variance, or we say smaller standard deviation. You can see that standard deviation we've gotten the other time is 2 for Judge A. But for Judge B, we've gotten something different. Now let's see. For Judge A have a smaller, Judge A have a larger mean and a smaller difference. So normally, if we check through the mean, we will say that Judge A seems to be harsher. We will say Judge A is harsh, Abby, because that is 33. 33 is more than 30. Everyone knows that. Judge A will say that. We conclude that Judge A is harsh. But at the same time, Judge A is fairer. He's very fair enough. Do you know why? Because the standard deviation of Judge A is very small, and that is just 2. Then Judge B is more lenient. If you consider the mean, we see that Judge B is lenient because it's going to give 30 years on average, but he is not consistent. Judge B is very lenient if you compare the mean, but looking at the standard deviation, it tells us that Judge B is not consistent. In that case, Judge B might be lenient at the first sight, but his lenient is not always consistent. It changes anytime. So it will be better that it will be better to face Judge A instead of facing Judge B. Even though Judge B has the higher mean, I don't know if someone is getting this. This is what we are trying to say. When you have a large variance or large standard deviation, this is telling us that we should not base on the mean. In fact, this is telling us that the mean can change to for how long. In another words, George A is our standard deviation to be 2, and the mean to be what? The mean happened to be 33. This is telling us that George A can give us 33 years old, 33 years in prison. In fact, George A can still give us 35 years in prison because the standard deviation is 2. If you add one standard deviation to it, that is telling us that we can still have up to like 35 in prison. But like George B is given 30 years in prison, but the standard deviation of George B is 8. This is telling us that George B can, in fact, give you 30 plus 8 years, and that is 38 years. So how far the variance or the standard deviation is telling you how much it can be wicked to. George B might be lenient, as you can see, but that does not guarantee you that George B will continue lenient. But George A is not lenient, but he will not be too harsh more than the level of the mean that you are given. So George A is very easy to be predicted. That is what we are telling you, is that 33 years, which was given by George A, we are confident enough that it will not go too far from that. That is what the standard deviation is telling you. But having 8 as standard deviation for George B is telling you that George B can go far to any extent. He might be lenient and he might go far and even harsh more than Stat B in some cases, more than George A in other cases. So I think you understand that. So what this thing tells us is that George A, which happens to be which has the standard deviation to be 2, will be consistent. It will be fair enough. It will never go too far from 33, which is its average predicted. But for George B, it can go any far as much as he wants. So you cannot face George B. So it will be advised that you face George A if you are to pick. So I hope you can get that. Yes. I hope you put in here. In the next video, you will learn how to calculate your standard deviation or the variance in another way. So I will be seeing you next class. So thank you.